Hello, I'm Joyeonju. I'm on master course in the chemical engineering department. I'm going to start presenting, and the research topic is a solid polymer electrolyte for lithium metal batteries. As awareness of the depletion of fossil fuel and environmental pollution becomes serious, interest in renewable energy is increasing. Wind, solar, and geothermal are the examples of renewable energy. However, these energies have some limitations. Those are dependent on climate and geography, so they are still difficulties in applying eco-friendly energy to real life. Energy is used in almost all fields, including residence, industry, and transportation. Therefore, these limitations should be overcome for various applications. In this context, there is a growing interest in technologies for sto storing, converting, and transporting energy. Energy storage technology can be generally divided into three categories: thermal energy, mechanical energy, and electrical energy. We will talk about secondary batteries that can store and consume electrical energy through multiple charge and discharge cycles. I am studying lithium-ion batteries among secondary battery systems. Compared to other secondary battery systems, lithium-ion battery has the advantages in applications due to its high energy density and lightweight. In addition, it has strengths for commercialization due to fast charging and long working. Based on these advantages, the demand for lithium-ion batteries is expected to increase rapidly, and they are attracting attention especially in electric vehicles or small IT devices and ESS field. First, let's talk about the overall mechanism of a lithium-ion battery. Lithium-ion batteries are made up of four elements: cathode and anode, separators, and electrolyte. The cathode serves as a source of lithium ions during the charge-discharge process, and the cathode materials determine the capacity and operating voltage. And anode electrode stores and releases the lithium ions from the cathode. The separator physically blocks the anode and cathode to prevent internal short circuit. Lastly, electrolyte is a medium that can transport lithium ions between the cathode and anode. Overall, the positive and the negative electrodes are related to the performance of the battery, and the separator and the electrolyte are related to the stability of the battery. One of the main issues for lithium-ion battery is to realize higher energy density. In order to increase energy density, it's necessary to increase the operating voltage and more higher specific capacity materials. For these reasons, higher voltage and higher specific capacity cathode and lower voltage and higher specific cathode anode, specific capacity anode are being investigated. However, there are serious problems in applying those to battery systems. First, um, when the high voltage or low voltage material is applied, then the electrolyte is easily to decompose. And electrode decomposition lead to reducing battery performance. In addition, lithium metal and silicon, which are attracting attention as next generation anode materials, cause serious side reactions in the current electrolyte systems. The second main issue is stability. Currently, commercial lithium-ion batteries use the organic solvent-based electrolyte, but organic solvents are highly flammable, so it may lead to the explosion accident. For resolving the problems of the current electrolyte, a solid electrolyte system has been proposed and attracted attention. Solid electrolytes are generally divided into polymer-based electrolyte and inorganic-based electrolyte and composite electrolyte. Polymer-based electrolyte is composed of polymer matrix and lithium salt. Compared to organic electrolyte, the polymer is cheaper and easier to process, and because it's very flexible, so it has good interfacial contact with the electrode. However, it has relatively low ionic conductivity and not good mechanical strength and low electrochemical stability. On the other hand, inorganic electrolytes has high ionic conductivity, and it also has high electrochemical stability and excellent mechanical strength. However, those are generally expensive and poor chemical stability. Also, it's very brittle, so the contact with electrode is poor, and the interfacial resistance is so high. Polymers and inorganic materials have opposite strengths and weakness. So when they are made into composite, their weakness can be reduced, while their strength can be improved. Therefore, I'm researching a solid composite electrolyte. I'm working composite solid electrolyte with semi-interpenetrating polymer network. This polymer structure helps improve the ion conductivity of the polymer while supplementing the mechanical strength at the same time. In addition, I'm researching ways to uniformly disperse inorganic nanoparticles to compensate for the inherent disadvantages of polymers. Solid electrolytes are currently at the R&D level, but research will be actively conducted for the batteries with higher energy density and safety. Lithium-ion batteries with solid electrolyte are expected to be commercially available in about 2027. Thank you for your attention.